Definitions before we begin. This is actually, you're going to like this. This isn't that hard at all. This is probably better than the probability stuff we've been doing. So, because it's actually just how many outcomes. It's not probability. Let me repeat that again. It's not probability. It's outcomes. So the first thing I need to introduce you is to what's called a factorial, which I hope you've seen and heard before. It looks like this, and with a little exclamation mark next to it, okay? And this is actually what it means. If you see something like 5 factorial, it means take the number 5, then multiply it by 4, 3, 2, and 1. Go all the way down to 1. If you see 9 factorial, you would do, guess what? 9, 8 times 7 is 6, 5, 4, 3, 2, 1. Exactly. Well, I can't even count. That's what factorial means. That is going to be important because those are inside of the formulas we're about to use for permutation and combination. Now, before that, there's something called the fundamental counting principle. Fundamental counting principle. And what it says is the number of ways, not probability. Remember, probability is under 1. It's a fraction. The number of ways a sequence of an event can occur is K1 times K2 times K3, etc. Let me give you an example. If you were to go to your closet right now and you were to pick out an outfit from 10 of your shirts and 12 of your pants and 5 of your shoes, I know you have way more shoes than that, you would just go 10 times 12 times 5. You just multiply the number of choices. That's it. Not probability, just how many choices are there. So just to give you an example of what the fundamental counting principle is like, how many ways, not probability, can you toss a coin, roll a die, and pick a card from a deck? Notice I'm not saying toss heads, roll a 5 on a dice, pick a queen, because then that would change the probability. This is just ways, okay? So how many outcomes are there on a coin? How many choices do you have? 2. How many outcomes are there on a dice?
6.
And how many outcomes are there in a deck of cards?
50.
So how many different ways are there altogether? You just multiply those together and you get 624 ways of tossing a coin, rolling a dice, and picking from a deck of cards. This becomes important when we talk about like passcodes or passwords. A password is made up of 2 digits followed by 2 letters. So I want to know how many outcomes is that. Password is made up of 2 digits followed by 2 letters. So what I usually do is, again, I kind of give myself these boxes. So I know that there's going to be 2 digits here, so a number, and then 2 letters here and here. So do you know how many digits are in our number system? There's 10. 1 through 9, and then the number 0 makes 10. So I have 10 choices for my first digit for a password. Then I have what here? 10. It wouldn't be 9.
It can be repeated.
Because you can repeat. If I had said, very good though with thinking that. If it said something about not repeating, then you would have to choose how many here? 9. Okay? So 10 times 10, how many letters are in our alphabet system?
26.
So you do 26 times 26. So how many ways is there to make a passcode of 2 digits followed by 2 letters? There's 67,600 ways. That may seem like a lot now, But think about how sophisticated our computers have gotten. Do you realize now that do you all have to change passwords like I do? Yes. And it's now becoming like include a capital letter. So that's now another 26 ways. Then they put include what? Like those, like a character, a special character. Yeah. That's because, so back in, I hate to say it, my day, like 20 years ago, this was a lot. A computer would take forever to do 67,600 ways to like hack into somebody's passcode. Now they can do that within like under a minute. It's way too quick. So they have to now change our passwords to be like, okay, it's got to be eight characters, one special character, a capital letter, a number. I mean, they make it so complicated so that way a computer system can't hack into it. Interesting. Yes. Isn't that crazy? And yet probably within the next couple of years, it's going to get even more crazier. So, all right, now let's talk about, let's talk about permutation and combination. And then we're going to start one of your worksheets. A permutation is an arrangement. Underline the word arrangement, where order matters. Let me give you a biggest example that I can always think of. Talking about like batting positions, okay? A lineup. A coach has to put together a lineup. His first batter, second batter, third batter, if he picks Jonathan, Drew, Rachel, that's one order, as opposed to picking Rachel first, Drew, Jonathan. Wouldn't that be a second order? Even though he's using the same people, that's two different ways, even though he's using the same people. So when order matters, you're going to hear words like arrange, order, first, second, third. Those are all permutations, okay? So the formula looks like this, NPR. NPR. This guy right here, this N, always is your larger number. So if I have like 9 players on a baseball team, how many different ways can I have the first, second, and third place positions? I would do 9P3, 9P3, okay? So this always is the larger number. The formula says this, N factorial, which we just talked about in the beginning, divided by N minus R factorial. So let me give you an example of this. Choosing a first, second, third place winner from a class of 20. First, second, third place winner from a class of 20. So this is a permutation because we got this first, second, third. Anything with order mattering is a permutation. You would put what number here in front of the 20? I'm sorry. 20. Thank you. 20. What would you put here? 3, right? You just have a 3 because you're doing, out of the 20, you're choosing 3, a first, a second, and a third. Now let's follow this formula. So what would go on top? 20 factorial. And on the bottom would go what? You just subtract these two. What's 20 minus 13? Minus 3, I'm sorry. 17 factorial. What that means is 20 times 19 times 18 times da-da-da-da-da-da all the way to 1, yes? Actually, I should do 17. The bottom is what? 17 times 16 times da-da-da-da-da all the way to 1. Do you know in mathematics you can cross off anything from top to bottom? So what's going to cancel? 17 all the way to 1, right? So what are you just left with? 20 times 19. That's it. Now, I'm going to let you cheat a little bit. I still need to see this on tonight's homework. I still need to see this on tonight's homework. But do you know your calculator obviously can do this? And the where you go is hit math, and then arrow over to where it says prob. Do you see NPR, NCR? And then even underneath is factorial, that exclamation. So you're going to hit NPR. If you have the new calculator, they actually put the boxes there. If you have the old calculator, you actually have to type the number first, then go to math prob. But this one, look, 20, move over 3, 6840 is the answer. So I still want to see this, and even this and this. But 6840 is your final answer. Pretty easy. So you're welcome. Yes.
We don't have to write out
you don't have to write out this. Nope. All right. And then one more, and then we're going to try a few of the homework. You got 2 worksheets to do tonight, and that's it. And they're easy. They're going to go quickly, I hope. Combination. So combination is different than a permutation because order doesn't matter here. When order doesn't matter. I'll give you an example. If you go to, a pizza store right now, this is one I always give, and, Jordan's like, I would like mushroom, pepperoni, and onions. And I come in after her and I'm like, oh my gosh, I want onions, then mushroom, then pepperoni. What is the pizza guy going to make? The same stinking pizza because they're the same ingredients. It's the same thing coming out. Order didn't matter. It didn't matter that she said pepperoni first, then onions, then mushrooms, as opposed to me saying onions, mushroom, pepperoni. It's the same pizza, okay? So what we have to do is we have to divide out those extras. So the formula says this, NCR, same thing, cool. And it would be n factorial on top again. It's always that n factorial. And it's same thing as a permutation, n minus r factorial, but you're dividing out all those extra combination, r factorial. So let me do just one example of this, and then we'll try some of our homework problems. Let's say I want to, I'm going to choosing 4 movies on Netflix. I don't know. From 10 movies that I liked. How many different ways can you choose 4 movies on Netflix from 10? Order doesn't matter here. It doesn't matter. You're going to watch the same stinking thing. I didn't say you have to watch, whatever movie first. I'm just saying you're just going to choose 4 movies from 10. So what number would come here? Which one's larger? 10, 4. I need to see that on tonight's homework. Then I need to see that you understood this formula here. So what number comes on top? 10 factorial minus these 2. What's 10 minus 4? 6 factorial. Then what's my R? I just need to see that. Let your calculator do the hard work. Math. Over to prob. Down to NCR. Put a 10. Put a 4, 210. There are 210 ways to pick 4 movies out of. Easy. Or so I say. Let's try some now. Oi. Shh. Here's your choices, and this is what's going to be very important. You have to determine, are we doing the fundamental counting principle, like I'm just going 10 times 8 times 12? Am I doing a permutation where order matters, like first place, second place, third place? Or am I doing a combination where order doesn't matter? So I will start you off and help you out with a few of these. Let's talk about number 1. 10 friends are at a party and they decided the party was boring and decided to go to a club. I know this is not Metrolina appropriate in 2 different cars. One of the friends, Susan, has an SUV that can carry 7 passengers. So Susan can take 6 more of the 9 friends with her. How many different groups of 6 are possible from the 9 remaining friends? Okay. So pretty much that whole story was insignificant except for the last sentence. How many different groups of 6 are possible from 9? Does order matter there? No. So this is a combination. So you would write what number in front? 9C6. Anybody remember what the formula is going to say? It's always the bigger number on top, 9 factorial over. Subtract these 2, 3 factorial, and then multiply it by 6 factorial. But that's all I want. Put it in your calculator. Tell me what you get. That's the answer. Easy peasy. All right, do number 2. Person is playing a card game called 21 in which they receive 2 cards from the dealer. If order doesn't matter, interesting, how many 2-card hands are possible? 52 deck in a card. Counting principle, permutation, or combination there?
Combination.
What would I write? 52. And how many are you choosing? 2 cards. Write the formula out for me. Get the answer. Students in a class. The students are instructed to line up on a set chorus stand that has 3 rows. The front row can hold 5 people. How many possible arrangements are there in the front row using 12 students? This is order mattering or not mattering? An arrangement? It matters. So it's a permutation. Okay. And how many kiddos am I choosing from? 12. And how many are in the front row? Okay. So put that in your calculator. Write the formula out for me. Easy breezy. And I'm going to do one more with you. You're going to finish this worksheet and okay, number 4, how many unique license plate tags can be created if each is 6 characters such that the first 3 characters can be any letter or number, but no character is allowed to be repeated in the first 3 characters, and the last 3 spaces can be any letter or number. Okay, so again, anything in here about order mattering? Well, there's this idea of it not repeating. Okay, but usually order mattering and it not mattering is between 2 things. Did you notice how permutation combination only has 2 numbers? 12 and 5, 20 and 2, 52, whatever. This one, though, I've got a license plate of 6 characters. So this is actually the counting principle. Because I've got to figure out how many of these 6 different characters I can have. The first 3 characters can be any letter or number. Ooh. How many letters are there again? 26. How many numbers are there?
10.
But start with the first one, though. 10. So how many does that make? So there's 36 possible choices of letters and numbers. Agreed? But now it does say no character is allowed to be repeated in the first 3. So then how many choices do I have here? And how many here? Okay. So we got that. Now let's go to our last 3 characters. The last 3 spaces can be any letter or any number. Was there anything about repeating?
Nope.
So how many letter numbers are there again? 36. 36. 36. There's nothing about repeating, so I can just keep multiplying it. Multiply all of them together, and that's how many different license plates can happen.
Would it be fine to have, because can you have 10?
We don't have a calculator, so we'll shut that up.
But you have 0 through 9, which is 10. It's really big. It's like 1 million, I believe. No, I take that back. It's 1 billion. 1 billion, some. All right, finish 5, 6, and 7. When you're done, show it to me and then come up and grab your last little worksheet, which is really easy too, and we're done.
I just put 199 gallons.